This is Josh White from JW Math Tutoring. In this video, I'm going to cover Digital SAT Linear Paper Practice Test number 5, the math section, specifically the unique questions that do not appear on any of the Bluebook practice tests. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I get started on these questions from Linear Paper Practice Test number 5, the unique questions, starting with Module 1, please be aware of the following things. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, these, as I mentioned, are the unique questions that appear on the Linear Non-Adaptive Paper Practice Test number 5. Okay, these are the questions that do not appear on any other Bluebook exams. So by completing these questions, you will not ruin, any potential Bluebook practice tests. If you want to copy these questions, there will be a link to a PDF file below, or you can, of course, download the entire Linear Non-Adaptive Paper Practice Test from the College Board's website. There'll also be a link to that in the description of the video. All right, so with all that being said, let's go ahead and get started on, again, Linear Paper Practice Test 5, the math section, module number 1, the unique questions. All right, first question we have here is number 2, and basically you have this film club starting with 90 members, and each day after the first day, 10 new members join. How many total members will it have 4 days after the first day? So this is just starting at 90. This is basically a linear function, really. And then 10 new members per day times 4 days means we're going to be adding 40 new members. Therefore, we will have 130 total members. The correct answer for this problem is letter B. Next up, number 3, here you have a graph of a linear function. What is the y-intercept of this graph? Well, it's just this point right here where the graph crosses the y-axis. So that's just the point 0, 8. Correct answer is letter D. Next up, number 4, you have a system of linear equations. What's the solution to the system? Well, notice r is given as 3. So right off the bat, we can get rid of these two because they do not have r equal to 3. And then you could just take it and plug it in here. And you could get s plus 21 equals 27, s equals 26. No, s equals 6, not 26. What am I doing? 27 minus 21. So the correct answer for this one is going to be letter B. Now, of course, you could go to Desmos and you could solve this in Desmos. I will tell you that if you want to use the graphing approach, then you're going to need to change S and R to X and Y. And I'm going to let X be R because that's what's listed first here. The first value listed is it's right here, R comma S. So R is X, S is Y. All right, so if we do this out, we can see here's the solution right here. Just 3 comma 6, that's our answer. Just so you know, too, if you instead wanted to do this using regression, you could keep the R and S, and you could do something like this. And then right here it tells you R is 3, S is 6. Okay, so if you want to do regression, then you don't have to change it. You don't have to replace R and S with X and Y. If you want more information on how to do this, of course, check out my Ultimate Desmos Guide to Digital SAT Math playlist. Next up, question number 5. Here you have a table of values. What is the best description for this function? Well, notice as the x increases, going down the table, the y values or the f of x values increase as well. So it's obviously an increasing function, so we can get rid of the 2 decreasing options. And this one is going to be increasing linear. It's letter B, because as we go through this, notice that we're just increasing, we're adding the same amount to get from one y value to the next one. Okay, for it to be an exponential, it would have to be multiplied by the same number or the same value to go from consecutive, y values 1 to the next to the next. But because we're adding the same amount, that tells us that this is a linear function. So the correct answer is letter B. Also, of course, you could just go to Desmos and you could just type a table. You don't have to type all these values in. Okay, and you could just say plot three of the points. And then you go to add regression. Linear, notice it's a nice line that goes through all three of them. That tells you it's a line. But if you try to do exponential, notice the r squared here is not 1. Okay. So that tells you that it's not a true, kind of like perfect fit to these points. And if you zoom in close enough, you can see the points are not actually on the function itself. It looks like they are when you're zoomed out, but when you're zoomed in here, you can see, no, this point right here, 0.17, it's not on the function. So that's what tells you it's not an exponential function. But be careful when you're zoomed out like this, it does look like a pretty good fit. It does look like an exponential model. But again, that is wrong. It has to be a linear function right here. The r squared value is 1. All right. Next up, question number 24. Which of the following functions has a minimum value at -3? So, a couple things. I personally would go to Desmos and graph these because these are exponential functions, and I think it's just easier to see. Uh, First of all, if they do have a minimum value, and if they do, where. So let's graph each of these. Let's get back to our default view. Okay. So notice these are basically like decreasing exponential functions. So as the x increases as it goes to the right, they both essentially go to negative infinity. So the point is neither of these functions have minimum values or specifically at -3. You know what I mean? Like if you just graph x equals -3, is this point the minimum value? No, there's much lower points, tracing all the way down here. Same thing with this function right here. Is this point the minimum value? No, obviously it keeps going down, so therefore there's other values that have lower x values. So the correct answer to this one's just going to be D. Neither of them have a minimum value at x equals -3. All right, so that was it from Module 1. Now we're looking at some questions from Module 2. Again, so on Practice Test 5. Linear paper non-adaptive test. Okay, first up, question number 2. What is the estimated pressure of argon when the temperature is 600? So on this graph, we're just going up to 600, and then we're going over to the pressure, which should be 12. So the correct answer for this is just going to be letter B. Next up, which expression is equivalent to this expression here? So basically, you're just factoring out a common factor here. And the common factor is going to be 2. It's also going to be x, y. And so these are out. And what does that leave you with? Well, 16 divided by 2 is 8. X cubed, take away 1x, you have x squared. Y squared, take away 1y, you have y. Okay, right away I know it's going to be letter B as the correct answer. But then just for the last one, it's just going to be left with a 7, and that's it. Also, just so you know, I won't go through the full steps, the full work, but you can do this one in Desmos as well. You could just graph. Let's see here. It will not give us a graph for the first one. So what we would have to do in Desmos is instead swap out x and y for a and b, add some sliders, swim to whatever random number, and then you would type the answer choices again, replacing x with a and y with b, and then you would see, do you get the same number for the original expression and for the correct answer choice? And so for answer choice B, we do. Again, I'm not going to bother spending the time going through all the others, but you could test them out and see that they do not give the same values that the original expression gives you. All right, number 9. Here you have a graph, and they want to know what is the x-intercept value mean here. So this is like 1.6, maybe 1.7 or so. What does this mean? So basically when time equals 1.6, the height is just 0 because it's right on the x-axis. So looking at these answers, is there a maximum height here? No. The diver hits the water at 1.6 seconds. Yes, the height is 0, which would mean that that's where the water is, since diver's starting on a platform above the water. Okay, diver reaches a maximum height at zero point 0.2 seconds. I mean, no, there's not an x-intercept at 0.2, so that doesn't even make sense. And same thing, diver hits at 0.2 seconds, there's nothing. That's where the maximum value of the function is, but that's not the x-intercept. So the correct answer here, of course, is just going to be letter B. All right, next up, question number 10. Here you have a quadratic function, and they want to basically know what k of 34 equals 5202. Interpretation of a function problem here, what that means. So notice, 34 is in the parentheses just like v. So that means 34 is equal to v, which is meters per second, i.e. a speed. So we should be looking down here for something that has 34 meters per second. Notice the only answer choice that has that is letter A. So by default, it has to be letter A. But you can also confirm then that the output, or the K of V, let's see here, which gives the kinetic energy, would be 5202, 5202. Where does it say? Oh, and here's the units, joules, 5202 joules. So that just confirms that A is correct. Next up, question number 11. Here we have a scatter plot, and we've got a line of best fit. For how many of these points is the actual y greater than predicted? So actual greater than predicted, that means we want points above the line. So how many are there? 1, 2, 3, 4, 5, 6. There's our answer. Letter C, and then we can move on to the next problem. All right, next up, number 20. We have a system of linear equations here. Now, I'll tell you, the quickest way to do this by hand is to add these two equations together and get 0 equals 15x minus 10, or 10 equals 15x. Notice they want 30x. So all you have to do is just multiply both sides by 2, and you get 30x equals 20, which is the correct answer. That's what, you would fill in. But of course, you can go to Desmos, and we can do the entire problem in Desmos. What is the intersection point? So here, okay, this is a great example to demonstrate something. This is a little annoying because we want 30 times this first value, which is the x, and we'll get rid of this. Okay, so notice it technically gives you 20.00001. Now, if you rounded this, you would still get 20. If you truncate, you still get 20. So you would still presumably get 20 and get the right answer. But notice it's not exactly the 20 like I did when I solved it by hand. So the way around that is you solve the system using regression. Let's see, we're going to have 5y. So again, if you want to know how to do this, want more practice with this, go to my ultimate Desmos guide to digital SAT math. It's in the advanced video part of it. All right, I just need to change these to y1. Okay, so now it gives me the exact values with no rounding for the solution point, which is x1 and y1 here. So now I just do 30x1. Now I get exactly 20. This is the technique you use for solving a system of linear equations or a single linear equation when you need or quadratic even, when you need the exact value to be used in a future calculation. Next up, question number 22. Here you have two rectangles. They're told they're similar, and the length of EFGH is 6 times the length of ABCD. The area of ABCD, okay, is 54. What's the area of EFGH? So, theoretical way to do this is to just note that the scale factor here is 6. In other words, you multiply by 6 to get from small to large. Therefore, the area factor will be that number squared, or 36. So you take 54 times 36, and that gives you 1944. That is the area of the larger rectangle. Okay? Alternate way to approach this. Say that the small rectangle has sides of 9 and 6. All right. So now, if each side is 6 times the length, that means this is going to be 54 and this is going to be 36. And then you could just multiply 54 times 36 for EFGH. That's basically what I just did previously. And if you do that, you should also get 1944. So that's kind of basically a picking numbers approach where you pick actual side lengths and then, calculate the side lengths in the large rectangle and then calculate the area. And you should get the same answer regardless of, which approach you take. All right, next up, number 25. Here you have an exponential question, exponential function, and they want to know basically what's the value of n such that an increase by 4% happens every n months. What's the value of n? So notice you have this 1.04 right here. Okay, a 4% increase in an exponential function is the same as multiplying by 1.04 because the 1.04 is made by doing 1 plus 0.04. 0.04 is equivalent to a 4%. I'm off the screen here. 0.04 is equivalent to a 4% increase. So the point is, if you have this function right here, okay, you need the exponent to essentially equal 1, and that would equate to a 4% increase because excuse me, then you'd be multiplying by 1.04, which is essentially what you do when you want to calculate a 4% increase. So in other words, 6 over 4t is equal to 1, or 6t is equal to 4. You just multiply by 4. Or t is equal to 4 over 6 or 2 over 3. But be careful, that is years, okay? So that's 2/3 of a year. They want n in months. So you have to basically say 2/3 years times 1 year, 12 months. Years cancel out. 3 goes into 12 4 times. It's equal to 8 months. Now, an alternate way you could do this, by the way, correct answer is letter A. I'm just looking at my notes here. An alternate way that you could do this is you can plug in, I'm just going to go to Desmos. Okay, so first I'm going to graph the original function here. I'm going to use x instead of t, okay? But everything else is the same. So first I'm going to get f of 0. I'm just going to let that equal a. Or no, I'm going to let that equal O for old. And because I'm going to calculate the percentage increase by plugging in all the answer choices. So in other words, I'm going to do f of 8. But here's the thing again you have to be careful with. Again, these are in months, so you have to take each answer choice and you have to convert it to years. So you have to take the number of months and you have to divide it by 12 to get it into years. So in other words, I'm going to take 8 and divide it by 12 to get this, and then I'm going to plug that in for f. Then I'm going to calculate the percentage increase, which is new minus old divided by old, okay, and then times 100 to convert to a percentage. So again, notice what I'm doing here is I'm starting with 0, okay? And then I'm saying, okay, if 8 months go by, converted that to years, 8 over 12. I plug that into the function. I get its output. And then I compare them and I see, was it a 4% increase? The answer is yes, because this number's 4. If you try it with the other answer choices, like change this to 12, now the increase is like 6.06%, which doesn't match the problem. Change it to 18. Now the increase is 9.23% over an 18-month period. Now change it to 72, which is 6 years. The increase is 42.3%. That's not a 4% increase that they're looking for in the problem. So this is how you could do it basically by taking the answer choices, plugging them in, calculating the percentage increase, and then seeing which one matches. Basically, it's back solving, which one matches the actual problem. Next up, we have question number 26. And for this question, what we have is a circle. We have the circle's center at -1, 1. And so let's see. So like right here's its center, -1, 1. And we have a line which is tangent to the circle at 5, -4. So that would say be like roughly down around here. So for example, if you're going to draw a line which is tangent to the circle, whatever, it's going to look something like this. And they want to know which of these points is going to be on the line, this tangent line here. This is line T. Okay. So there's multiple ways that you could do this. First thing I would do is I would basically draw the radius here from the center to the point of tangency, find the slope between those 2 points. Now, of course, you could do this in Desmos. I'll just going to do it by hand. 1 minus -4 and also -1 minus 5. So I get 1 plus 4 is 5 on top, and -1 minus 5, -6 on the bottom. So the slope of the radius is -5/6. Therefore, the slope of line T is the opposite reciprocal of that. The reason being that a line which is tangent to a circle and the radius drawn to the point of tangency are perpendicular. That's a theorem from geometry. So therefore, the slope of line T will be the opposite reciprocal. So we flip, put the 6 on top, 5 on the bottom, and we change it from negative to positive. So the slope of this line is +6/5. Okay. So now, if you want to do this by hand, basically what you have to do is you could take y equals mx plus b. All right, and we can plug in the point and the slope. So we know the slope is 6/5. We know the point is 5, -4. This is going to cancel. So it looks like b is going to be equal to -10. Okay, so the equation of this line is y equals 6/5 x minus 10. And then you're basically looking for which of these points is on this line. And you can just go through and plug them in one at a time, and you can see which one works. Basically, it's going to be letter C, because 6/5 times 10, 5 goes into 10 2 times. 6 times 2 is 12. 12 minus 10 is 2. We get 2 equals 2. It checks. However, I would definitely recommend using Desmos to check and do some of these steps, if not most of them, just because it will be so much easier and so much quicker. Actually, so let me just zoom out briefly. Okay. See if I can get some more of it on the screen here. All right, so first of all, obviously in Desmos, like I said, if you just want to find the slope between the two things, you can just put them in a table, then you can click on the automatic linear regression. Okay, there's our slope. The only problem is we don't have the exact number, so if I'm going to do export now, I have the slope stored as m. So if I wanted to find, so what I would do is I would type m, and it gives me this number, right? And then I have the actual fraction here at -5/6. So now I want the opposite reciprocal of that. So I'm going to do negative. So first I'm going to put a negative, and then I'm going to do 1 divided by m. So that gives me 6/5, right? So this is the slope of the perpendicular line, the tangent line, line T. So now what I would do is I would make a table, and I would put in the 5, -4 point, and I would do a regression, which you have to notice here. I'm all the way up on y3, so I'm going to type x3 and y3, and now I would do just type in 6/5 x3 minus b. Okay. So just to show you again, what I've done so far just in Desmos is I found the slope of the line connecting the radius, the radius, which starts, here's the center, and here technically this is the point of tangency. And then I took that value, I found its opposite reciprocal, which is 6/5. Then I took that 6/5 and I took the point that the line goes through, and I got the equation, or specifically the graph, of line T right here in blue. Let's turn this off. Okay, so the blue line, that's all we're concerned with. And now what I would do, even if you found the equation of the blue line by hand, I would just type it in and then go to Desmos and just plot the points. And you're going to see that, like, this is answer choice A. Is this on the line? No. Okay, let's go to 4-7. Answer choice B. Is this on the line? No. Okay, let's go to 10-2. Letter C, is it on the line? Yes. And we could do 11-1 just to check, but you wouldn't need to really. D, is it on the line? No. So I would suggest that once you get the equation of the line, whether it's in Desmos or not in Desmos, just go to Desmos, graph out the points, graph the line, and you can easily, it's just quicker than like going through one by one and plugging them in. Unless, you want to do it in your head, like, then go ahead, that's fine. But the correct answer for this one is going to be letter C. All right, so I hope you enjoyed the solutions to these problems from Linear Non-Adaptive Paper Practice Test number 5. Again, the unique questions that do not appear on any of the Bluebook practice tests. If you have any questions or comments, please do leave them below. Otherwise, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And also check out the other videos for the solutions to the unique questions from the other linear paper practice tests. And lastly, if you are looking to improve your knowledge of Desmos, please do check out my ultimate Desmos guide to digital SAT math, over 3.5 hours of tips, tricks, instruction, and 45 practice problems to help you master the digital SAT math section.